Hey there, 8th grade. Today we're talking about percentages on their own. So in the past we talked about how to convert between percentages and fractions and decimals, and we're going to need to know how to do that for this. But in this case, we're really just talking about what sort of calculations can we do with percentages. And I'm going to give you one equation that we can use for all sorts of percentage problems, and I think it's probably the easiest way to think about it. Some other people might teach you proportions and whatnot, but we'll probably just go with this for now because it's kind of the one way to understand percentages that can answer any sort of question. So let's get some notes before we get into some examples. First note is that when expressing a percentage, we're expressing the ratio of a part to a whole. So that's what a percentage is. Just like fractions and decimals talk about a part of a whole, that's what a percentage does. So even though 17% sounds like it's greater than 1, 17 is greater than 1, 17% is actually part of a whole. It's a less than 1. So let's talk about a little bit more about these words we're using here. One of the key words is whole, but other people will talk about that as the total or the base. So if you have you got a 97% on a test, the total number of questions would be the whole, the total, the base. That's the complete set. So you might get 97%, and you can see this next note says that another way to think about that would be 97% would be the rate of what you got 97% out of 100. That was the rate that you got questions correct. For me, it was more like 37%, but that's okay. But percentage or rate is another keyword that people use interchangeably. Next note you'll see is this is the equation that we're going to use all the time. So it's percentage times the total will give you a part. So if you multiply the percentage times the total, you'll find out what the part is. If I say what's 15% of 300, we usually think of as meaning multiplication. So 15% of 300 means 15% times the total 300. It will, when you multiply, it'll spit out the part. It'll tell you what is that part, which is equal to 15%. The way I usually notate this, and I write it before I solve this equation, is percentage sign. I use that as a variable because variables can be any symbol that stands for a number, times total, whether it's capital T or lowercase t is up to you, equals the part. We use P to designate part. But hopefully some of you are thinking, well, if you did 15% of 300, wouldn't that be bigger than 300? And if 15% is a part of 300, it should be smaller. In fact, it'd be 45. That's correct. So what we don't do is we don't multiply by 15%. We don't multiply, or by 15 the number, the whole number. What we have to think about is we usually don't multiply by percentages. We multiply by fractions and decimals. So we'll change that percentage, 15%, into a fraction, like 15 over 100. Or we'll change it into a decimal, like 15 hundredths, 0.15, and then we'll multiply by the total. And that would spit out the part for us. So that's an important distinction to make. So let's move forward and see how it works out in some examples. This first one says, what number is 16% of 1,800? So what I'm going to do here is I'm just going to go straight with that equation, and I'm going to say, okay, we want to know percentage times a total, and I'll do capital T this time, equals the part, or P. Well, which do we have? Well, it's easiest to pick out the percentages, so I can fill in 16%. And in this case, let's do it first as 0.16. So 16%, I know that I can change that to decimal by moving the decimal twice to the left. And then we're going to multiply by the total. What number is 16% of 1,800? 1,800 there, we're looking for the part. What number is the percent? What number is the little chunk? So 1,800 must be the total. So we're going to do 16 hundredths times 1,800, and that's going to spit out our part. It's going to give us the part. So over here, let's do it over here actually. We'll do our multiplication, and if we have 1,800 and we multiply by 16, this is just two-digit multiplication, which we should all be very familiar with. 16 hundredths actually, so I know my answer better have two decimal places, because we're just going to ignore it. We're going to act like we multiplied by 100. We'll have to divide by 100 at the end. 6 times 0 is 0. 6 times 0 is 0. 6 times 8 is 48. Carry my 4. 6 times 1 is 6 plus 4 is 10. So we got a big number to start with. Now we need a placeholder 0. Then 1 times 0 is 0. 1 times 0 is 0. 1 times 8 is 8. And 1 times this 1, I know it got kind of messy, is 1. Now we need to add. What are we going to get? 0.00882. Okay, now the last thing I need to do is put my decimal back in. So we need to move it 2 places back into our answer. Now we already have our answer, 288. That number is 16% of 1800. Now we want to think, does that make sense? Does that seem reasonable? Well, 16% is much less than 50%, so we should have much less than 900. It is. This makes sense. Another way you could have done this is if you wanted to write the percentage as 16 over 100 and then multiplied by 1800, that would also work, and a lot of people are going to like that because it just kind of knocks out these zeros right away. If you divide both these by 100, then you'll just get 16 times 18, and you would get the same answer. It would also be 288. So I just want to show you that. But really, that's just, we're just going to use that equation, make sure we change the percentage into a decimal or a fraction, and then move on ahead. Let's see another example. So here we go. This says, what percentage of 256 is 96? So again, same equation. We're just going to say percentage times a total should give us a part. Now, which is which? We don't have a percentage here, so we have a total and a part. What percentage of the total? So we use of, and usually after that comes our total. So 256 is 96. And now you're maybe beginning to see why I like this method so much. It's because we spend a lot of time on solving equations. We get really good at it. And now we're solving for this percentage, this variable here. So we're just going to go through our equation solving method. We have to undo what's been done. It's been multiplied. We'll divide both sides by 256. Those will cancel, and it should give us our percentage as a decimal, though. It will give us our percentage as a decimal, because remember, in the equation, this is given as a decimal. So 96 divided by 256. Fill in some zeros because we know that it's going to be given as a decimal. We'll say how many times does 256 go into 960? And I would say that would be 3 times. 3 times 6 is 18. 3 times 5 is 15 plus 1 is 16. 3 times 2 is 6 plus 1 is 7. Now we could work this out as most people do with regrouping to do the subtraction, but 960 minus 768 means we're almost just going to subtract 760, but we're going to subtract 8 more. So 960 minus 760 would just be 200, but we need to subtract 8 more. That would bring us down to 192. Hopefully that made sense. Bring down a 0. Now in this case, let's try and think about this first. Well, when we multiplied 256 times 3, it got us 768. If we multiply by double that, or by 6, it would give us over 1,500. So let's try 7, because we have some room, wiggle room from 1,500. So let's try and multiply by 7. 7 times 6 would give us 42. 7 times 5 is 35 plus 4 is 39. And 7 times 2 is 14 plus 3 is 17. In this case, we'll just subtract the old-fashioned way. We'll regroup. 2 from 10 is 8. 9 from 11 is 2. And 7 from 8 is 1. Bring down that last 0. 256 into 1,280. That's probably 2 less than this. So let's try 5. 5 times 6 is 30. Looks good so far. 5 times 5 is 25 plus 3 is 28. Still looks good. 5 times 2 is 10 plus 2 be 12. Okay, we found this answer. Phew. So the percentage in decimal form is 0.375 or 375 thousandths. To change this decimal to a percentage, this ugly written decimal into a percentage, we need to multiply by 100 and move the decimal twice to the right. So the actual percentage would be 37 5/10%. That's the percentage. So again, we got to remember that when we use this percentage value in our equation, it's as a decimal. So to get the actual percentage, we need to change it back out from decimal form. The percentage is equal to 375 thousandths. What percentage is equal to 375 thousandths? 37 and 5/10%. Let's look at another. I need to freeze real quick. So let's go into this last problem, and as we look at it, I apologize for that delay, or a little skippage. It says this is a word problem, so we're going to go through the same process, but maybe take a second to explain how we get these values. You are taking an online survey. After you complete question 24, it says that you are 15% done. How many total questions are there? Same exact equation. Percentage times total, percentage in decimal form, times total equals the part. What do we have? We have 15%. So 15% times our total. Do we know what the total is? It's asking for the total, so we don't know what that is. Times the total equals the part. And the part we have is we're on question 24. That's 15%. Now again, before we can multiply, we need to change this to a multiplying form or multiplying and dividing form, which would be a decimal or a fraction. So if 15 hundredths times total equals 24, again, just equation solving method, undo multiplication by dividing both sides by 15 hundredths. Our total in this case is going to be 24 divided by 15 hundredths. Now 24 divided by 15 hundredths, hopefully you remember that if the decimal starts over here, we need to move it twice to the right before we can divide, because we had to divide whole numbers. But we also have to move this decimal twice to the right because we multiplied both numerator and denominator like equivalent fractions. We multiplied them both by 100. 15 goes into 24 once. When we subtract, we'll just get 9. 15 goes into 90, I think it's 7 times. 7 times, oh no, it couldn't be 7 times. Oh, what a mistake. 16, okay, sorry. It's 6 times, whoops. You guys probably knew that, I just didn't. So here we go, we'll say, because 15 times 2 is 30, and there are 3 groups of 30, so 2 times 3 would be 6. So 6 times 5 is 30, carry a 3. 6 times 1 is 6, plus 3 is 9. Subtract, we get 0. Now the important thing here is we realize that this decimal is one place value over, so we actually need to say, bring down this last 0 and say we don't have to go into 0 any times. So the answer in this case is 160. You could also tell that doesn't make sense, because if you're on question 24, and you're only 15% of the way done, then there probably aren't 16 questions less than you've already done. So this is 160 questions. Ooh, fancy writing, not really. Okay, that's the last one I'm going to show you guys, but I'm going to leave you with some to do on your own as always, so check them out. The first one is what percent of 45 is 9? You got to figure out what is the percentage, what is the total, what is the part, plug them into that equation. Number 2 is 18 is 20% of what number? So imagine, is 18 the part or the total? Best of luck.